Hi guys, this is Miss Gold. Today's lesson is Module 2, Lesson 2, using the number line to model and understand addition of integers. Your goals for today's lesson are students model integer addition on the number line by using horizontal arrows, such as an arrow for -2 is a horizontal arrow of length 2 pointing in the negative direction. Students recognize that the length of an arrow on the number line is the absolute value of the integer. Students add arrows, realizing that adding arrows is the same as combining numbers in the integer game. Given several arrows, students indicate the number that the arrow represents, or the sum. Students understand addition of integers as putting together or counting up, where counting up a negative number of times is counting down. Students use arrows to show the sum of two integers p plus q on a number line, and to show that the sum is distance absolute value of q from p to the right if q is the positive and to the left if q is negative. First thing I'd like you to do is to pause the video so that you can complete the opening exercise 1 on your own. And when you're ready to continue, just unpause the video. So take a moment to look over the key to exercise 1. You'll notice that this is a real-world situation, and real-world situations can be modeled with equations and represented on a real number line. In this exercise, positive 10 represents the $10 given as a birthday gift because it's a gain. Negative 4 represents 4 spent on snacks because it is a loss. And I want to note here that a lot of us tend to think that if we spend money, that would be subtraction. And that actually is true. You could take 10 and subtract a positive 4. However, the directions clearly stated that you needed to use addition, so you had to do it in this way. And that's something that we're going to explore in further lessons. So gaining $10 and then taking away 4 will leave you with 6, and we represented both of these using an equation but also on the number line. Let's take a look at example 1. Complete the steps to finding the sum of -2 plus 3 by filling in the blanks. Model the number sentence using straight arrows called vectors on the number line below. Place the tail of the arrow on. So the first thing we need to figure out is, where do we start? Well, we talked about this in the previous lesson. We are always going to start from 0. So let's start at 0. Part B says draw the arrow 2 units to the left of 0 and stop at. So if we're going 2 units to the left, that's going to leave us at -2. The direction of the arrow is to the left since you are counting down. Start the next arrow at the end of the first arrow or at -2. So this is similar to an example we did yesterday. So we're going to start here just above. Draw the second arrow. Now we want to add 3, so we're going to go 3 units to the right since you're counting up from -2. So let's go up 3 units. 1, 2, 3. And that leaves us stopping at 1. So here we know that this represented the -2 and this represented the 3. For F, it says repeat the process from part A for the expression 3 plus -2. So what they did here was they simply switched the order of these two numbers. So let's try that. Start at 0. Go up to 3. From there, we're going to start the next arrow, or the next vector, and we're going to go down 2 units. And that leaves us at 1. So what can you say about the sum of -2 plus 3 and 3 plus -2? Does order matter when adding the numbers? Why or why not? Well, you'll notice that the answer we got when we added these two numbers either way was 1. So it didn't make a difference which order we added the numbers in or the integers in. So we'll say -2 plus 3 is equal to 3 plus -2 because they both equal 1. And basically what we know is that the order doesn't matter because of a specific property, and that property is called the commutative property. And you'll be hearing about and using this property quite a bit, so you want to become familiar with the term commutative property. In example 2, you'll notice that this is really just a way to show you that we can look at number lines not just horizontally, but also vertically. A lot of people like seeing them vertically when they're talking about real-world situations. Think about moving up and down a mountain or going above sea level or below sea level. Because those contexts literally talk about movements that are up and down, it really helps people to visualize the scenario. So notice that with counting up, as in adding +4 here, we would start at 0. We first are adding 2, and then we're moving up 4 units. Now in this case, notice they go up by 2s for each one. So this case, we're going from 2 up to 6. So you can visually see that you are moving up 2. On the other hand, take a look at adding -4 to a +2. So we start off the same way with moving from 0 to 2, but in this case, we're moving in the opposite direction. Adding a negative is the same thing as essentially subtracting. So we are going to move down towards the -4 units, and this brings us down to -2 as a final answer. In example 3, they ask us to find the sum of the integers represented in the diagram below. Write an equation to express the sum. Okay, let's take a look at example 3. Example 3 asks us to find the sum of the integers represented in the diagram below and write an equation to express the sum. And what they've done is they've broken the steps down into 3 different parts so we can see what are the things that we should start to think about when we're asked this type of question. So as I look at this diagram, I notice that there are 3 different motions going on this number line. So the first one represents a +5. So in terms of the cards referring to the integer game, we would definitely have a 5. The second one is a -2, so we would have a -2 card. And the third one is a +3. And we know because they're represented using the arrows, length and direction. Part B says, can you make a connection between the sum of 6, meaning the final answer of 6, and where the third arrow ends on the number line? So notice here, if we actually drop down the end of the third arrow, it's right at 6. So that really tells us that the final position of the third arrow gives us the sum. Part C says, would the sum change if we change the order in which we add numbers? For example, starting with -2, then adding 3, and then adding 5. So we could kind of go through and see if this would make a difference. We'd start with 0 and move down 2 units. That's representing our -2. From there, I need to add 3. So above here, I'm going up 3 units. And from there, I'm going to go up 5 more units. So if we go above here, 5 units is still going to take us to a final position of 6. And the reason we know that is actually because of the commutative property of addition. So we can state, no, addition is commutative. In this lesson, you have learned on a number line, arrows are used to represent integers, and they show the length and direction. The length of an arrow on a number line is the absolute value of the integer. Adding several arrows is the same as combining integers in the integer game. And finally, the sum of several arrows is the final position of the last arrow.